In continuation to previous video, here we'll calculate the degree of freedom for the based on this Cook's-Bragg criterion. In the Cook's-Bragg criterion, degree of freedom can be calculated by n is equal to 3l minus of 1 minus of 2j minus of h, where l is equal to number of links, j is equal to number of binary joints or lower pairs which has got 1 degree of freedom, where h is number of higher pair which has got 2 degrees of freedom. So you will be applying Cook's-Bragg criterion for different structures where you'll be able to calculate the degree of freedom or to find out the mobility of the structure. So here a, a structure is given where you are supposed to find out degree of freedom for the given mechanism, where you'll be able to calculate the degree of freedom. So we'll be using Cook's-Bragg criterion where L, J and H are supposed to know, where L is equal to number of links. So as in the structure ABCD, the number of links are 5. So L is equal to 5. So number of joints is equal to 1, 2, 3, 4. So here as per the previous definition J is equal to number of binary joints which are supposed to calculate. J is equal to 6 it comes. So 1, 2, 1, 2, 3, 4. Fifth joint is there. So number of joints are 6. And number of joints with no degree of freedom, it is 0. So if you calculate substituting the equation, so n is equal to 0. So degree of freedom is equal to 0 means the mechanism forms a structure. So further, if you take another diagram where it has got rotations with respect to two fixed two fixed two fixed joints. So here 2 and 5 are will be able to give rotation with respect to the constraint and with respect to joint 1. So here number of joints are number of links elements are 5, number of joints are also 5, number of joints are also 5, number of elements with higher degree of freedom it is 0. So further if you go, n is equal to 2 here. Two inputs of any two links are required to yield definition motion in all links. So here you have to give inputs to any two links so that you're going to get the definite motion in all the links. So like this it is defined. So further to calculate degree of freedom, here you can see here is given different structure where it has got a frame. So here number of links as per the definition in the first problem in the numerical example 3. So number of links are 1, 2, 3, 4, 5 and 6. If you take number of joints as number of joints, if you count in the first frame it has got 3, in the another frame 3 it has got 3, 3 plus 3 6, 6 and another one is there 7. So 7th is considered, so j is equal to 7 and h is equal to 0. If you substitute in the expression degree of freedom is 1, means if we give input to any one link, that will result in definite motion that is defined here. So further if you take another structure or problem number 4, so for this you can see that at the intersection 2, 3, 4 are there, which has got two layer pairs has to be considered. So here you have to count the number of joints. So number of joints are 6. Number of lower pairs it is considered as 7. Number of higher pairs as 0. So if we substitute in the expression, you will be able to get degree of freedom as 1. So further if we take another structure where it has got number of links and with a frame structure which is connected with respect to the constraint link 1. So here the number of links are 11, number of joints are 15 with lower pair, number of joints with higher pair as 0. So if we calculate degree of freedom as 0, here he defines which has got two lower pairs at the intersection 3, 4, 6. It is there 3, 4, 6. There is uh, 3, 4, 6, 2, 4, 5, 5, 7, 8, 8, 10, and 11. It has got one joint but two lower pairs at the intersection. So yeah, suppose calculate here degree of freedom is 0 means it is a structure. If degree of freedom is 1 means it has got a mechanism which has got single input motion. If degree of freedom is 2, then it is got a constrained motion for the mechanism. It is minus 1 since it is redundant constraint in the chain. So like this, we'll be able to define the structure. So we'll see some problems on higher pair. When we go with higher pair, here you can see the number of so here it is a in the first problem what we can see is number of pairs as number of links as 3, number of elements with lower pair as 2, and number of joints with higher pair it is 1. So you'll be able to calculate. So degree of freedom is 1. So further, if we consider a wheel constant with respect to one end, so number of links are 4, number of elements with lower pair it is 3, number of elements with higher pair it is 1. So that is the wheel at the surface it is considered as higher pair. So 1, 2, 3 here it is lower pair. It is with the links where it has got joints. 1, 2, 3. 1, 2, 3 with respect to link joints. Here you'll be able to find out where it has got a lower pair. So here the degree of freedom is 2. Like this, you'll be able to calculate the course batch criterion for higher pair. So further, if you take another structure where it has got three, three, 3 points where it is constrained with a joint. So number of elements here it is going to count it as 4. So where all it is constrained, there it is 1, and another joint is 2, 3, 4. So number of links are 4. So number of joints if you consider here it is 5. So number of higher pair are 0. So here it's an indeterminate structure. So if you consider two cams rotating and fixed at one end, so number of links has 3, number of joints with lower pair has 2, number of joints with higher pair it is considered as 1, where it has got a line cutter. So if you calculate, so n is equal to 1 year contingent. So like this, you'll be able to apply Cook's batch criteria.